Humanity is producing more data than ever, but that knowledge remains stranded by the limitations of a page-based interface. A new open-source project called ArXiv Paper to Podcast offers a direct structural fix to this reading barrier. The software automatically converts any technical archive paper into a conversational two-host audio podcast. Instead of scrolling through pages of complex equations and tiny text, a user simply inputs the paper's link and gets a ready-to-listen MP3 file. By doing this, the tool shifts the consumption of academic research from a demanding task requiring your full attention to an effortless act of passive listening. This diagram shows the exact four-step automated pipeline that makes this possible. The architecture moves the data from a raw URL input all the way to a finished audio output. At the first station, the code calls the archive interface to locate the paper. Then it uses pymupdf, a software library highly optimized for reading PDF files, to extract exactly 15,000 characters of text, stripping away the rigid grid lines, headers, and visual clutter. The clean text is then handed off to the Anthropic API, passing the data into Claude. Claude is a large language model, or LLM, a type of artificial intelligence trained to understand and generate human text. The specific prompt instructions fed to Claude do not ask for a simple summary. Instead, they command a structural translation, rewriting the dense findings into a back-and-forth dialogue between two distinct personas. This specific step is the crucial bridge in the architecture. It turns static, one-way data into a dynamic, two-way narrative script. The third station takes that generated script and connects to the ElevenLabs API. ElevenLabs provides text-to-speech software that uses deep learning to generate highly realistic synthetic human voices. To anchor the dialogue, the software hard-codes two specific voice models, named Alex and Sam. Finally, at the fourth station, the system uses pydub. Pydub is a Python library designed for manipulating audio. It takes these dozens of separate, alternating voice generations and stitches them together into a single, cohesive audio file. Within this assembly code is a variable called TTS_pause_ms. This parameter intentionally injects exactly 400 milliseconds of dead silence between one speaker finishing their sentence and the next speaker starting theirs. By automating these specific micro-silences, the code replicates the natural cadence of a human exchange, making the transition between speakers feel seamless. The final output of this entire pipeline is a ready-to-publish MP3 file, capable of explaining highly complex topics to anyone who wants to listen. But the code for this repository wasn't written by humans over months of development. It was generated autonomously by an AI agent named Neo. This creates a recursive loop. An autonomous AI agent engineered a piece of software specifically to help humans understand other newly published AI research. An autonomous agent can conceptualize and assemble this type of pipeline with a speed that human development teams rarely match. With autonomous tools building the pipelines and language models translating the contents, the path from a technical paper to a morning commute listen is shorter than it has ever been.